Hello students. So today we will take topic related to solid solutions. In case of materials, if we consider the materials, different types of materials are available. That is, some materials are pure materials. Then for increasing the properties of material, like if we want to increase the material like corrosion resistance, so we add some materials who improve the property of material. So if we add more than one material, then that material is called as alloy. So solid solutions are related to alloy materials. Here, our today's topic for discussion is related to solid solutions, and this solid solution is related to alloy material. So if we see the structure of alloys and phases in alloys, so it contains two different types. In case of alloys, two different phases are there. First phase is solid solution and second phase is, that is, compound or intermetallic components. If we consider solid solution, so in that solid solution, variation in composition is possible. So if we consider the two materials, then in that two materials, one material which is act as a solute, and another material which is act as a solvent. Mostly the solute is, if we compare the percentage of solute in case of that alloy material, the percentage of solute is mostly minimum. For example, if we consider, this is the atoms. In these atoms are called as solvent, and if we add another material, then that atoms are called as solute. Here at two locations, that solute is go inside in between this solvent. So if we compare this solute and solute having the less quantity as compared to solvent. So variation in composition is possible, meaning is that if we add more amount of solute, then it gives different properties. So this type of variation is allowed in case of the solid solution. Next, usually the crystal structure of solution is that of one of the components. Consider this is one material, this is another material. And here the crystal structure, if we see for this alloy material, then crystal structure which is related to one of the material in between these two materials. Okay, so this crystal structure is possible. If we compare this with this compound or intermetallic component, then composition is fixed, composition is there. No variation is possible in case of compound. So if the percentage of solute and solvent becomes fixed, then that solution, material is fixed throughout. That is called as compound. If we see the next, that is crystal structure, which is different from either of the components. So if we consider, this is material 1 and this is material 2. This solvent is material number 1 and this solute is material number 2. If we add both these together, then we get alloy material, and that alloy material shows different crystal structure. Okay, so this is the difference between solid solution and compound solution. So lot of possibilities are there in case of solid solution, because when we vary the solute material or percentage of solute, then automatically we get the different properties of the material, that alloy material. Okay, so our today's topic is related to this solid solution, not this compound solution. Now we see some examples in case of solid solutions. Our first example is related to austenite. In case of austenite, this is solid solution of carbon in gamma ion. This Fe is nothing but ion. So solid solution of carbon in gamma ion, and it gives the FCC structure, that is face centered cubic structure. If we see the second example, this is the solid solution of carbon in alpha ion, that is alpha Fe. So carbon and alpha Fe combination is there, and the crystal structure is BCC structure. This BCC structure is body centered cubic structure. This is one of the crystal structure out of these two materials. If we see the third example, this is alpha brass, which is solid solution of copper, that is FCC, and zinc, that is HCP. If we consider the copper crystal structure is FCC and zinc crystal structure is hexagonal close pack, that is HCP. This is FCC's face centered cubic structure. So in case of this alpha brass material, solid solution of alpha brass has FCC structure. So these are the two components, copper and zinc. We know that according to their definition, the crystal structure becomes one of these two crystal structures. So copper having FCC structure and zinc having hexagonal close packed structure. So we prefer this FCC crystal structure, that is face centered cubic structure. So these are the examples. Now we'll see the types of solid solution. Okay, two different types are there. First is interstitial solid solution and second is that is substitutional solid solution. Okay, interstitial solid solution and substitutional solid solution. If we see the atoms in the alloy, we know that alloy means the combination of materials together, that is called as alloy. So if we consider these big size circles are related to solvent atom, and if we combine all this or if we arrange this like a structure, then in between these type of gaps are present. These gaps are called as voids. And if we add another material in the first material, then that material occupies the empty spaces, that is voids in this case. So these small size atoms occupies these voids or occupies these gaps. These atoms are called as solute atoms, and these big size circles, that is nothing but that is also atoms that become solvent atom. So solute atom occupies the voids of this solvent atom. So solute atom sits in the voids of crystal structure of solvent. And if we see, this is circular and this is also circular. If we see the size of solute or radius of solute is much less than radius of solvent. From this diagram itself we know that radius of solvent is much greater than radius of solute. So this is about interstitial solid solution. Now we go towards the second type, that is substitutional solid solution. Now here the solute or atoms occupies the empty spaces or occupies the voids, but in case of this substitutional solid solution, this solute atom not occupies the voids but it replaces the solvent atom itself. In this case, this is actually initially solvent atoms, but in that solvent atom, that solute atom goes, okay, and it replaces the solvent atom. So solute atom replaces the solvent atom from its regular crystal site. So in this case, both the size, that is radius of solute and radius of solvent is same. So here R solute is nearly equal to R solvent. So in this way, here we finish the types of solid solutions, and today we already discussed about the solid solution, that is alloy material and then types in that alloy material, that is solid solutions, then compounds, and then we focus on solid solution. What is the meaning of solid solution? We learn that today. And also we see the types of solid solution. In that also we discuss about the crystal structures. We already see the crystal structures also related to some of the examples we are taking, and we already learned about that crystal structures also. So here we stop. Thank you.